this example, we will format two disks, one with a basic FAT file system and one with a Reliance family file system. Each disk has a boot block, the FAT has a file allocation table, and the Reliance disk has two meta routes. These are used to point to the current and last known good state. Creating a file on each file system is done pretty much the same way. Write the data blocks and then update the system blocks, in this case the FAT or the meta route. Each time we write a file, we change the state of the media to the next known good state. When updating a file on the FAT file system, some of the existing data is overwritten. When updating on Reliance, a copy of that block is made, and after a successful transaction point, that original block becomes a free block. This approach ensures that no good data is overwritten. While this appears to cause fragmentation, on flash media the blocks are wear leveled and therefore usually non-contiguous. So what happens if the power is interrupted? This file update will be interrupted by a power failure. Some or all of the file data is written, but the system data write does not complete before the power is lost. On mounting the disk after the power is restored, the state must be verified. On a FAT file system, these blocks contain partial data. The file system may pass verification, but only the application will know if what was written here is valid. In this case, essentially the entire file can be considered garbage. If the application does not immediately validate the data, the corrupted data might not be detected until a long time after power failure occurred. Tuxera's Reliance file system must merely determine which disk state is the current one. To do that, we only have to read a few blocks off the media. In the known good state, these blocks are still free, and this file is still good. For data integrity, there is no substitute for using a true transactional file system like Reliance Nitro and Reliance Edge.